In some of our previous videos, we've looked at how ENERCALC for Revit manages various different types of loads on a beam, including non-hosted loads, hosted loads. In this video, we're going to be specifically looking at a few cases where loads, multiple different load cases, and different load objects overlap with each other with similar geometries and similar locations, and look at how those loads are mapped into the ENERCALC interface. So again, we're going to be looking at this main entrance canopy area. If we look at the second floor, the two conditions that we'll be highlighting are this beam right here and then this beam. So if we go to the section looking at this beam, this is not really designed to be a realistic loading scenario, but it's just a demonstration scenario to show how this will be mapped into the ENERCALC interface. So we have all 7 of the different load cases that ENERCALC for Revit supports, all stacked on top of each other with similar geometries. And we're going to go ahead and look at how this maps into the ENERCALC interface. So instead of mapping as individual line items and creating more and more lines of load here in the ENERCALC interface, these are all mapped together as a single line item with the individual cases populated with the appropriate magnitude. So this is just sort of a convenience organizational feature to keep things clean and kind of reflect the design intent of what the user has modeled in the Revit interface. The second example we'll be looking at is this beam, and in this case, instead of having differing cases with the same geometry, we have repetitive cases, all dead loads, with similar geometry all lined up on top of each other. And so in this case, we'll see when we launch the calculation that these loads are actually going to be mapped into the ENERCALC interface with individual distinct line items. They're not going to be added together. They're not going to be consolidated. They'll be individual here on the cantilever span. And so we see that we have our 0.25, 0.35, and 0.45 kips per foot individually, and they've been kept separated so that they reflect the design intent of what was modeled